right, so for this one in Leetcode 763, partition labels, they want us to take a string and then partition that string so that letters only appear in the same partition. So for instance, if you have an A, it's only going to appear in a partition where there's A's. If you have a B, it's only going to appear in a partition with B's. And if you have a C, it's only going to appear in a partition with C's. So you couldn't do something like this, because in this instance, B is appearing in both partitions, and you couldn't do something like this because A and B are appearing in both partitions. So that wouldn't work. The letters have to be in their own separate partition, but you can have different letters in the same partition. So I hope that wasn't too confusing, but just know, same letters, same partition. Okay, so the first thing we need to do is look at the string we're given here, and let's just put that inside. So as the example states, I want two partitions like this lead to the letters being in their own separate partition. So what I really need to do first is grab the last index of each letter. And the reason I'm doing this is because I need to know where the partition starts and ends. So let's make a variable called last, which is just an object. And then I'm going to loop through the string. And I'm basically going to grab each letter. So let's say letter is equal to S at I. And then I'm going to assign it its last index and then assign that value to the last object. So I'll say last at the value of letter is going to equal, and then I'm going to say last index of. So this method I'm applying to this string, and it's going to give me the last index of whatever letter we're currently looking at. So for instance, the first pass, it's going to grab A, and it's going to say, oh, the last index of A is 0, 1, 2. So the last index of A would be 2. When it reaches B, it's going to look at B and say, what's the last index of B? Well, this is 1, 2, 3. So the last index of B would be 3. So just like that. So let's console log last to see what we have so far. And you can see, oh, it's actually using this value right here, I believe. But the same concept holds true. I'm recording the last index of that specific value. Okay, so now that we're doing that, we basically need to figure out where our partitions start and end. So what I'm going to do is make a variable called end. I'll set it to 0, and then I'll make a variable called start, and I'll also set that to 0. So I'm going to loop through the string again and basically figure out where to start and stop each of these partitions based on the last index of value that we have stored in the last object. So let's loop through the string again. So we're looping through the string, and now we need to look at our letter and update the end partition. So let's use that letter variable again just to make it more clear. So I'm going to look at the letter, and I'm going to say this end variable needs to update itself accordingly to the letter I'm on and its last index. So I'll say let end equal math.max. I'll pass in end, and then I'll look for the last object with letter. So what it's doing is it's going to look at A, and then it's going to say, is the end index of A greater than end? And because end is set at 0 at the start, it will be. So this will be updated to 0, 1, 2. So now the end is 2, and we're going to loop through the string, and now we're at B. So it's going to look at B, the letter B, and it's going to look in the last object. What is the last index of B? Well, that is 1, 2, 3. So now we have 2 and 3 because 3 is from B. So of course, end now becomes 3. So it's going to continue this pattern of updating itself when it crosses a letter whose last index is greater than end. Well, if we don't put a condition to stop it, it's just going to keep going across the entire string and just keep updating end, because last letter is going to be, C, and it's going to have this last index here. So what we need to do is say if end equals I, we need to do something. So if end equals I, we know we've gone too far and we need to stop and record our partition. So what I'm going to do is I'll make a variable called partition, set it to just an array like this, and then I'm going to add our partition by using the push method, and I'm going to push in end minus start plus 1. And the reason I'm adding the plus 1 is because, as you know, array indexes start at 0. So if I just took the end minus the starting value of these indices, I would actually be 1 off. So I'm compensated by adding the 1 here. And then I need to update the start value, because start is no longer going to be at 0. Start actually needs to be I, where we are currently at, plus 1. So what does that look like? So we're gonna start here, update our last indices. We're gonna get to B. Notice that our last indices is greater. Keep going, keep going. We're gonna get here, and this is going to be triggered because now the end equals I. So we know this is a partition that we need to take. So we're going to take the end index, which is right here, minus the start, plus the 1, and it's going to grab all of this, and we're going to put it into the partition array. Okay, now we have updated our start. So our start is updated, and then we're going to do the same process for C, and it's going to grab that partition of C. So what we're actually doing is we're recording the length just like they want in this example here. So let's return. Let's first console the partition. So this is for this problem right here. You can see it's giving us the 978, which is pretty good. So all we need to do is just return the partition. All right, there you have it. Thank you for watching, and keep working hard, guys.